Hi Panthers. Today we are going to talk about graphing exponential regression. So we have the graph y equals 3 parentheses 2 raised to the x. We want to know whether that's linear, quadratic, or exponential. So anytime we have something raised to an exponent or a power, we know that that's going to be exponential. So this is exponential. Our exponential equation is y is equal to a parentheses b raised to the x. The a is going to be our initial value. The b is going to be our growth or decay factor. And the x is our time. And so when we look at the 3, we know that that is our initial value. And so if I was to go graph that, I would put a dot there because that's 0, 3. This 2 tells me that this is going to be a growth, and so it's going to increase from left to right. And so my values, or my x's, are going to increase as my y. And so from left to right, it's going to be increasing. I also know that since it's exponential, that it is never going to go in and cross this x-axis right here, and it's going to just be getting bigger. And so if we were to go sketch that, we know that it'll look something like this. Might not be perfect, but we can go sketch it. Looks something like that. We'll have arrows, so it'll keep going. And we also have a little dashed line right here along the x-axis, and this is going to be our asymptote. And since this is horizontal, this is my horizontal asymptote, which is going to be y equals 0, which means that this graph is reaching towards this line. It will never reach it, and that's what an asymptote is called. So to answer all these questions, we want to know what the domain is. The domain is the x portion, and we look to see, do we have a left and do we have a right? And we do not, because our graph has these arrows, and so our domain is going to be all real. On exponential, sometimes we write it as x is greater than negative infinity and less than positive infinity. So be aware that you can see domain written that direction. The range, when you look at it, is not going to touch my x-axis, so my range has to be y is greater than 0. I do not have an equal because it will not touch that line. Horizontal asymptote, we've already talked about that, and that is going to be y is equal to 0. They also might say the x-axis. The x-intercept, so that means that it would actually have to cross my x-axis, and my exponential does not cross, and so I do not have any, so that would be a none. And the x-intercept is going to be my a value, and that would be an ordered pair, which is 0, 3, and so this is the a value. So on this, we just know that b is greater than 1, and so that is where we get our growth. So looking at number 2, it says, what is the solution of 2 raised to the x equals 0.5 x plus 2? So what we're going to do is that we are, since these are both set equal to 0, we can think about it as y is equal to y. And we are going to just go sketch these graphs, set them equal to 0, and come up with an intersection. So the first thing we're going to do is we'll need our calculator. So take a second and go get your calculator. And so we're going to go to our graph, and in our graph, we are just going to go in and we're going to go in and graph 2 to the x. And then hit enter. So I'll write the steps after I get done. The next thing we want to do is we want to graph this other side. And so in order to do that, I have to hit tab. So what we've done is we go to graph, enter our equation. Hit enter, and now we're going to hit tab. So now we're ready for the second equation, and we're going to put 0.5x plus 2, and then hit enter. So now we have two graphs. And so now what we're going to do is we're going to look for the intersection. And so we're going to press menu, number 6 for analyze graph, and then we're going to look for an intersection. And so we're looking for an intersection. So number 6, so I went menu, number 6, and number 4 for intersection. So we have two x values. We have one over here, and then I have another x value, which is right here. And so this dotted line, you're just going to move this dotted line back and forth, and you want to hit the red and the blue someplace close to where your x is. So I hit enter, and then I move the dotted line so that it crosses where both those graphs touches. And when I do that, you can see that I'm looking for the x value. So this x value is equal to negative 3.86. And then I will go through those steps again. I'll go menu, number 6, intersection, which is number 4, and then I'm going to bring it over on the other side, and I just want to bring my dotted line so it touches the two graphs, and then I'll move so I get the intersection, and this is going to be x is equal to 1.44. And so the intersection just means that that dotted line has to touch both graphs someplace. So you didn't have to bring it that close. You could have run it over here and then just ran your line across. And so our answer to that solution is going to be two answers, which is negative 3.86 and x equals 1.44. On number 3, it says sketch f of x equals 3 parentheses 0.2 raised to the x. So the things that I know, that this 3 is my initial value. That's going to be my a. I know that's my y-intercept. And I also know that this 0.2, since this b value is greater than 0 and less than 1, I also know that this is going to be a decay. And so I know that this is going to decrease as I go from left to right because it is a decay. And so we can go ahead and pick up our calculator to go see what it looks like. And we're just going to have just a little graph, little sketch over here. 1, 2, 3, because we have to have a y-intercept of 3. And then you can go ahead if you would like to go pick your graph up or calculator up and see what it looks like. And so you can type in 3 parentheses 0.2 raised to the x. And this should show that you have, as you go from left to right, that it's decreasing, and that even though it looks like it's going to cross the x-axis, it doesn't. It just gets very, very close. And down here is your asymptote. And so it goes very steep, comes down, and goes like that. And then we have this dotted line right here, and so this is our asymptote. So what is the domain? And so the domain is we're looking for our x value, and we do not have a left, we do not have a right, and so that's going to be all real. We also remember that we can write it like this. with the infinity. Our range is going to be the values that are all this direction for our y. So y is greater than 0. We do not have an equal because it will not ever touch that. Our asymptote is going to be this line right here that it's reaching towards, but will never equal that. And so y is equal to 0, and that's going to be our x-axis. The x-intercept is our initial value, which is 0, 3, and it will never cross, or will never get to the x, so we'll have no intercepts. All right, number 4. The function modeled below represents the number of square kilometers of land occupied by cane toads X years. So this is my X because we're talking about years after the animal was first introduced into Australia. So the question is, after 40 years, what will be the measurement of square kilometers of land occupied by the cane toads? So we have to write an equation because they did not give us an equation for this. So we want to go ahead and put this into the calculator and let the calculator help us out. And so this is going to be a regression. Just like all the regressions that we do, we go to the calculator and we have to go to lists and spreadsheets. We're going to put the x and the y values in. We're going to press menu 1, and then this is where it differs. Once we get to the screen where we get to pick, we are going to pick letter A for an exponential regression. So I'll walk through this with you. So we're going to go to number 4 for lists and spreadsheets, and then we're just going to type in our data, and we want to put the x and the y up here. And then we'll just type in our data 0, 5, 10, 15, 20, 25, 30, 35. And then you can go all the way back up and then put in your kilometers. Okay, so then you want to make sure that you go ahead and enter all the data. So you want to come off, and then you can go ahead and, as long as you're in just any screen, you're going to go ahead and press the directions say. You're going to press menu, and then you're going to go number 4, number 1, and then here's where we go a little bit different. We're going to go look for exponential regression, which is letter A. And then our X list, which was X, you put X, your Y list, which is Y, and then you go click OK. And we do not have anything to do with R because that's just linear. And we're going to go in and write down, this tells us we wrote an equation in the form A times B raised to the X, and we're going to write down our values. And so our equation is going to be y is equal to, and I'll write down the A value, and we'll write down the B value. And so our A value is 36492, and I'll just go click on that so we can see it's 36492.18, and I'm just going to round that to the nearest tenth, and that's 0.2. Our B value is 1.08. We'll put those all together, and that's going to be 36,492 and 2/10, 1.08 raised to the x. And so that is our equation, and we get all of that from the calculator. So the question says, after 40 years, and so this is going to be our time, what will be the measurement of square kilometers of land occupied by the cane toad? then that's just a matter of figuring out where do you plug in. And this is going to be my x. And so I have y is equal to 36,492.2 raised to the 1.08, and that's times 40. And so you can hit Control Dock, and then add your calculator, and then just go ahead and type away. And that is going to be y is equal to 792,776, 792,776 kilometers square of land. If you wanted to go back here, you can just move your mouse around and you can go click on 1.1, and that will go in and give you that data. All right, so the next one is the table shows the number of bacteria in a culture after the given number of hours. Predict what the number of bacteria will when you reach 10,000. Okay, so I want you to go in and see if you can come up the equation. And once you get the equation, come back, and then I'll show you how to make the prediction. So go type this into your calculator, and then get the equation, and then I'll show you what to do with that. Okay, so you should have found that your A value is equal to 1,753.72. Your B value is 1.12. So put that all together, and your equation is y equals 1,753.72 times 1.12 raised to the x. So now we're going to make a prediction. And so our prediction is we want to know when will the bacteria, which is right here, which is our y, is equal to 10,000. So we're going to take this equation and we are going to graph it. So on your calculator, you're going to pick it up, you're going to go to your graph, and you are going to go graph 1,753.72 raised to the 1.12x. And then we're going to hit Control T. So now we're going to go look to see when does our y equal 10,000. So I'm scrolling down. And I see that my my bacteria is going to be somewhere between 15 and 16, but I want to be a little bit more accurate than that. So we went to a table, which was Control T. So what we're going to do, we're going to hit Menu. We're going to hit number 2 for Table. And then we are going to edit the table settings, which is number 5. And I want to change my table settings to 0.1. And so this is going to get, over here, this is going to get my time to the tenths. So I should be able to get a little bit more accurate. And I will go back and show you again. So we changed the step to 0.1. So we went Menu to 5 and changed the step to 0.1. And so let's go see if we can get that closer to 10,000. And so 15.3 is going to be 9,931, and then 15.4 is very, 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 very close. And so we're going to call that at 15.4. And so then y is equal to 15.4. And so then we want to go ahead and get that to our minutes. And so we know that 0.1 minute, or 0.1 of an hour, is equal to 0.6 minutes. And so we also know that 0.4 hour would equal 24 minutes. So this is going to be 15 hours and 24 minutes. So at 15 hours and 24 minutes, we would have right around 10,000 bacteria. All right, we want to solve 3 raised to the x equals 81. So we are going to go ahead and we're going to graph both of these. And so we're going to go ahead and we'll graph 3x. And so that'll be y is equal to 3x. And then we're going to graph y equals 81. And so I want you to go ahead and do that. And we're looking for what the x value is. All right, so when you put that into your calculator, so you would go ahead and graph, I'm going to graph y equals 81 first. And when I do that, I don't see it, so I'll hit menu, number 4 for zoom, and I'm going to zoom out. And I keep hitting that, and so that's what my graph looks like. And then I'll hit tab, and then I'll hit 3 raised to the x power. So it looks like that. And then I'll go menu, number 6, analyze. I'm looking for the intersection. And then this says lower bound, so that means that I've hit my graph, and I'll just go ahead and move it until I see the intersection. So this tells me that my x value is 4. So I want you to go ahead and you'll do the same thing over here. So we're going to go graph. We'll graph y is equal to 5 parentheses 2 raised to the x. We're going to go graph y is equal to 40. And then we're looking for the x value. On this one over here, you'll graph 4x plus 4. You'll set that equal to y. Then you'll graph y is equal to 68. And you're looking for your x value. So go do those two. We'll come back and compare answers. You should have come up with x equals 3 for this one. And then over here, x is equal to 3. All right, the last two says the value of a car is given by the function c equals 22,000 parentheses 0.75 n. So we already know that this is going to be a decay, or as a car, we call it depreciation, where n is the number of years since the car was purchased. Which of the following best represents the range? So we're looking for the y value. Which of the following best represents the y value? And so you're inputting your time, and you're going to get your y value, which is your cost. So we know it's not our time because that is going to be our domain. So we would cross out our f and our g. And so we're looking for the cost. And so domain on a real world, would that be negative infinity to a positive infinity? Well, that wouldn't make any sense because the car definitely would have a limit on its value. You would have a minimum value. So this one right here would not make any sense. So it's going to be h. So the maximum value is going to be $22,000, and the minimum value would be 0. It wouldn't go any lower than 0 because even if you crash the car, you would get a 0 value. It would not be a negative. So that would be letter H. On this one, it says, what is the range of the function? So f of x is equal to 6 parentheses 0.04 raised to the x. And so we want to know what is the y. So another name for f of x is y. So we're looking to see which one of these makes sense. And so we also know that this is going to be a decay, and it's decreasing, and it's going to start up here at 6. And then you ask yourself, do I have restrictions? So I have no restrictions. But I do have a horizontal asymptote, and so it's going to decrease. It's not going to go in and cross the x-axis. And so my range is going to be greater than. So I'm looking to see which one is greater than. And so y is greater than 0.